Good morning, Math 8 students. On to determining probabilities using fractions. All right, so up to this point, we've only used tree diagrams or tables of outcomes in order to figure out the probabilities of different independent events. So two things happening that don't affect each other. Today, what we're going to learn is how to multiply the probabilities of one event by the probabilities of another event to make our lives a lot easier and calculate the odds of both of those things happening together. All right, so what we've got here is a spinner that goes from 1 to 10 and 6 playing cards. So we've got Jack, Queen, and King of Hearts, and Jack, Queen, and King of Spades. That's 6 total cards. Now, I could ask you to make a tree diagram or an outcome table for this, but that's going to be a lot of work. That's going to be 60 total possibilities because there's 10 possibilities here multiplied by 6 possibilities here. That's an awful lot of work to do, and we can get to that answer in a much more simple way. So how we're going to do that is simply multiply the odds of something happening in the first event by the odds of it happening in the second event. In this case, the question asks us how to determine the probability of spinning a 1 and drawing a jack. So let's look at the two odds of those things happening. For the spinner, well, there's only 1 out of 10 on the spinner, that's a 1. So 1/10 is our first fraction multiplied by, in the second event, there's 2 jacks out of 6 total cards. So 2 out of 6. When we multiply our fractions, it's top times top, bottom times bottom. 1 times 2 is 2, 10 times 6 is 60, and I reduce that to 1 over 30. So the answer is the odds of spinning a 1 and drawing a jack are 1 in 30. Pretty simple, a lot easier, and it makes a lot more sense to do it that way than to make a tree diagram. All right, let me just change my pointer to a laser here. Move on to example number 2. So same two events. We've got the spinner, we've got the cards, except this time, let's look at the question. It wants the probability of an even number on the spinner and a king from the cards. So here we go. Our first event, well, out of the 10 total numbers, 5 of them are even. 2, 4, 6, 8, and 10. So that's 5 out of 10 as our first fraction, multiplied by 2 out of 6 for our second fraction, because 2 of the 6 cards are kings. 5 times 2 is 10. 10 times 6 is 60. I can reduce that to 1 over 6. Now, you may be asked to provide answers in different forms. So 1 out of the 6 is a great answer, but if the question asks you to answer it as a decimal, well, 1 divided by 6 is 0.17. Or if the question asks for a percent as the answer, 0.17 is 17%. You have to be comfortable with all three of those different types of answers, and we're going to actually calculate some percentages in probability the further we go. Okay, so same two events. This time, I would like to determine the probability of greater than 3 on the spinner and a black card from our cards. So just a reminder, the less than and greater than symbols, you can always think of this as the symbol wants to eat the bigger number. That's how you know exactly which direction it faces. So the greater than is what we're working with right now. If you look at our spinner, greater than, well, that does not include the number 3. It has to be bigger than 3. So how many different choices do we have that are greater than 3? Well, we've got 1, 2, 3, 4, 5, 6, 7. So 7 out of 10 is our first fraction. And then the black cards, there's 3 out of 6. So that's our second fraction. 7 times 3 is 21. 10 times 6 is 60. I can divide a 3 into both of my answers here. So 21 over 60 becomes 7 over 20. And again, 0.35 is the decimal version of that, or 35%. Simple. All right, last example with these two events. This time, I want the probability of a multiple of 3 on the spinner and the Queen of Hearts from the cards. All right, so just a reminder, I should say, the multiples of 3 are 3, 6, 9, 12, 15, etc. So on our spinner, there's 1, 2, 3 of those multiples. So 3 out of 10 is our first fraction. And there is only 1 Queen of Hearts. So 1 out of 6 is our second fraction. 3 times 1 is 3. 10 times 6 is 60. I can reduce that to 1 over 20. or 0.05 or 5%. All right, on to a question that is actually quite difficult. You'll see some questions when you do your practice work here that only deal with percentages. And typically, these are just word problems. They're not even going to give you a diagram to work with here. Okay, so let's read very carefully through this question. Then, for the next two examples, we're going to have to use the percentages they gave us along with some complementary outcomes, some complementary percentages to find the answers. All right, so a school soccer team wins 50% of games they play on rainy days. So if it rains, there's a 50% chance that they win. And they win 60% of the games played on fair days. That means it's not raining, it's sunny out. Okay, so 60% on days when it's not raining. And we also know that the weather forecast says that there's an 80% chance of rain the next game day. So the next time they play, 80% chance it's going to rain. Question asks us determine the probability that it rains and that they win. So we've got to be really careful about which numbers we select here to go into our formulas. Again, there's two events here. Whether it rains or not is the first event, and whether they win or not is the second event. We're going to take all the percentages we use, we're going to turn those into decimals. That's the easiest way to use, well, anytime we use percentages in a calculation, we should turn it into a decimal first. All right, so here we go. The odds of it raining are 80%. That's what it tells us there. So 0.8 is my first fraction. And then if I go up to the statement that they win 50% of games they play on rainy days, we've got to use that number because it's raining. So the second number we use is 0.50, which is the decimal version of 50%. And I multiply those two together, I get 0.4. I will turn that back into a percentage. And the answer is there's a 40% chance that it will rain and their team will win. Okay, last example we're going to do today. So same question, except this time we're looking for the probability that it does not rain and that they win. So let's look at this first event here, the does not rain part. If there's an 80% chance that it rains, the complementary outcome to that is a 20% chance that it does not rain. Remember, all percentages need to add up to 100%. So if it's an 80% chance of rain, that means a 20% chance of fair or not rain. So our first number here is 20%, which I've turned into 0.20. Now, we need to pick which number works with the not rain or the fair day. So we're going to use the 60% here. I turn that into 0.6. 0.2 times 0.6 is 0.12. And as a percentage, that's 12%. That means that there's a 12% chance that it will not rain and the soccer team will win. Okay, guys, quick lesson today. What we need you to do is please complete some practice questions. There are some practice questions in the class notebook for you to do, as well as on page 432 of your textbook. Numbers 4, only B, 5, 7, 10, and 16. That seems like a lot, but most of these questions are fairly simple, straightforward, just one calculation, and you're done. Please check your answers in the library, content library, I should say, under week 7, lesson 3. Good luck. You'll do great. Have a great day.